Hi, everyone, and welcome. Thanks for joining today. I'm Travis Steele with Red Hat, and I'm joined by Arian Salgado. Hi,
Hello,
Arian.
everyone.
So, today we'll be covering a wide range of topics around securing the software supply chain. So, Arian, this is a huge area for the government today, especially in modernizing software factories. What do you think some of the major hurdles are when securing the software supply chain?
I mean, when it comes to software supply chain, there are many, many hurdles. We could spend all day really talking about it, but I'm just going to focus on a few here, right? Uh, First and foremost, I would say the complexity of software ecosystems, that vast and intricate network of libraries, dependencies, and tools that make up a modern software application. It introduces numerous points of vulnerability, and each component, often deployed by different teams and organizations, can carry its own security risk. Then, of course, there's legacy systems. The DoD is full of legacy systems. Now, DoD software factories often have to integrate new software with existing legacy systems, which may not have been designed with modern security practices in mind from the beginning. This presents significant challenges in ensuring secure end-to-end supply chain without compromising the functionality of the integrated systems themselves. And then finally, of course, we got the rapid technological evolution. That fast pace of technological change means that new vulnerabilities are constantly emerging, which especially legacy systems have a hard time of keeping up with. And it's a constant struggle. Those are the ones that come to mind.
Yeah, I think those are great points, and you touched on a lot of the complexity that's in the environment today. That's coupled with complexity of bringing new technology and new capabilities. There's a lack of visibility, a lack of control, certainly human error that contributes, and then dependency risk. When we think about hurdles, uh, what dependencies are there today? Do you know about them? How critical are they to the total supply chain, and who's providing what, where, and when? So there's a lot to unpack there, and I think this is at top of mind for everyone. So those are really great points.
Of course.
Ariane, what's working today in DoD organizations that are engaged in software activities?
I mean, there's really a lot that is really working today. There's a lot of things that they've actually brought here recently that are making a big difference. I would say right off the bat, the adoption of DevSecOps practices, just integrating security as a fundamental aspect of the development and operations process, it helps in identifying and mitigating vulnerabilities early. That's a huge, huge deal there. Also, containerization and microservices architecture, that's something that's really come up here recently. Just utilizing containerized environments and microservices, it allows the DoD software teams to isolate applications, making them scalable and just really easier to update as well. And then, of course, the main subject of our conversation, software factories themselves. The DoD has been establishing software factories, dedicated facilities that adopt modern software development practices, which include agile methodologies, automated testing, and continuous delivery. Again, we could keep on going with this, but those are some of the big ones that I've noticed here recently.
Yeah, I think those are really good ones to call out. As the government and industry navigate the secure supply chain and the challenges and the complexities, it's easy to point out and really be critical of what's not going right because of the amount of work that has to be done. But in reality, everything's maturing. It's maturing at pace.
Right.
There is a lot of synergies between different agencies, how they're working together, how they're organizing. There's emerging frameworks on top of the guidance that's been given from executive orders to even recent guidance from CISA and OMB around the secure attestation form. So
Right.
they're, secure by design, and how it feeds into the secure supply chain is critical. And there is a lot of progress and a lot of successes, but yet a lot of work to be done. Let's talk about governance. To achieve compliance is critical across the government. What type of industry slash agency collaboration is required to create an adaptable framework?
I think one that's really important here is public-private partnerships. engaging with partnerships between government agencies and private sector companies, and really leveraging industry expertise in cybersecurity, software development, and supply chain management. That's huge. These partnerships can really drive innovation in secure software development practices and technologies. And then also, I would say standard development organizations, or SDOs, as they're more commonly known. Some of you might have heard of already of NIST, the National Institute of Standards and Technology. Such partnerships are crucial for developing, refining, and adopting cybersecurity standards and practices that are both robust and flexible. What do you think, Travis?
You hit the nail on the head. Partnership, partnership, partnership.
Right.
Government to government, government to industry, and industry to industry. If we're going to solve this problem together, we've got to be open. We've got to share information. We've got to have the right partnerships in place. And then it's got to come under the responsibility of regulatory alignment so that everybody's working from the same sheet of music, from the same core responsibilities and expectations. Without it, I don't think that we move to a state of continuous readiness and understanding the full supply chain and how to secure it from beginning to end through the entire life cycle of an application. So governance is absolutely critical. Governance can't be underscored enough with its importance to bringing compliance through the entire supply chain. So Arian, how and what should organizations consider regarding artifact management within the software supply chain?
Great question. This is absolutely key to secure software supply chain, right? First things first, I would say security and integrity, ensuring the security and integrity of artifacts throughout the entire supply chain. This includes implementing cryptographic signatures, checksums, and secure storage solutions that prevent tampering and unauthorized access. And then I would also say provenance and traceability. That's huge with this. That's really built in. Maintaining clear provenance and traceability of all artifacts. This means knowing the origin and history of each component, including who created it and how it has been modified over time. This is essential for assessing security risk and compliance. Implementing tools and processes that can automatically document and track this information really is key.
Yeah, really great points. I think one of the things that should be considered is a universal artifact manager that would allow, organizations to gain total control over all components of their software supply chain. That would include everything from managing artifacts, binaries, packages, and other components to help streamline the delivery process, ensure better traceability and management of the software components. And of course, gives you those elements that you described around, version control and access control, checksum verification, and secure repositories. Building off artifacts, let's talk about transparency and traceability. These are key tenets to achieving a trusted software supply chain. Arian, what will it take to accomplish this?
Let's start with comprehensive tooling and automation. Implementing tools that automatically log and manage the lifecycle of all software components. Next, standardization of protocols and formats. Adopting standardized protocols and formats for documenting and exchanging information about software components and their dependencies. Efforts like Software Package Data Exchange, otherwise known as SPDX, and Cyclone DX. They facilitate the sharing of component metadata across tools and teams, which enhance traceability. And then how about secure and immutable artifact repositories? Using secure repositories that support signing and verification of artifacts is really key. These repositories should enforce strict access controls and record a tamper-evident log of all operations, ensuring that every change is auditable and traceable.
Arian, great points. Transparency provides visibility to stakeholders and suppliers. It ensures confidence and trust by revealing strategic supply chain structures and management practices. Traceability is more transactional, focusing on tracking how products progress through the supply chain. It manages inventory, key performance indicators, and also costs. Having visibility to what is in the code, who introduced that code, where in the supply chain was that code introduced, and the provenance of that code throughout the life cycle is really key. Being able to audit that information is key. That delivers that trust and that provenance that you spoke about. You also brought up a really good point around the different formats for metadata that come through things like the secure bill of materials or SBOM. I think it's important that organizations really coalesce around a single standard so that industry, developers, and organizations alike can have a single expectation of what to provide and how to provide that information. The signatures that you talked about, how you obtain those, how you store those, how you ensure that there's nothing that's been modified, all fit into the transparency and traceability model. Uh, and it's going to take a collaborative effort. No single source of development or code is out there, especially in today's world. You've got roughly 90% of all software includes open source components, and over 90% of developers today use open source in their coding. And so these are third party components. They're upstream, they're downstream, and it's very important to traceability to know where that code's coming from, who developed it, and why was it inserted into the application that you're using. And so this is a life cycle problem that's never going to go away, and it can only be through collaborative efforts with industry and organization to organization that can solve it. Ariane, during that last question, you brought up automation. How can automation be leveraged to streamline and accelerate the processes?
This is a big question. There's a lot that can be automated. But just to name a few for now, I would say I would like to start with continuous integration, continuous development, otherwise known as CI/CD, which really just means automating the build, test, and deployment processes using those actual CI/CD pipelines. This not only speeds up development cycles, but it also ensures that security checks are integrated into every phase, allowing for immediate detection and remediation of vulnerabilities. Then how about automated security scanning? This integrates automated security tools such as static application testing, which is SAST, dynamic application security testing, DAST, and software composition analysis, SCA, into the development lifecycle. I know it's a lot, but really important. Then there's so many others. We got infrastructure as code, we got container orchestration, and automatic compliance checks.
You're right. Automation has a lot under the covers. It's both very, very capable. It's powered by technologies like machine learning, artificial intelligence, and digital process automation. And it can significantly help organizations. But at the same time, I think there's a lot of hesitancy in organizations around utilizing automation. Um, it's a lack of control that comes into play for organizations and individuals. And I think that without automation, getting to some of those automated security scans you're talking about, policy enforcement, patch management, really leveraging the CI/CD pipeline, becomes a very complex task, especially for a lot of code development and iteration on applications. So if we're going to stay ahead of the adversary in terms of the DoD, the need for automation and deploying new capabilities, updating and preventing, attack vectors and vulnerabilities, things like that. Automation has to play a key role in how to streamline and accelerate the processes. Okay, Ariane, as we kind of conclude our session today, what advice do you have for others on their journey to securing the supply chain? And do you have any good examples out there for folks to look at today?
So top of mind right now, as far as somebody that is doing it right, really Platform One is a great example. Right now with their services with Iron Bank and Big Bang, they're making changes that impact the entire DoD right now. And they really are serving as a great example for others to follow. And their architectures out there for anybody to really copy and take advantage of. As far as advice, I would say start with a strong foundation first. Really begin by assessing your current state, identifying critical assets, and understanding the flow of software and data across your entire supply chain. Implementing foundational security practices such as secure coding standards, access control, and encryption of sensitive data. Great place to start. Next, I would say prioritize transparency and traceability. Work towards achieving full visibility and traceability of every component within your software supply chain. This includes understanding the origin, journey, and modifications of each component, which is crucial for managing risk and responding to threats effectively. And then also embrace DevSecOps. Not really much more I really need to go into that. We all know that DevSecOps is the way to go. And I would say also invest in education and training. Cultivate a culture of security awareness within your organizations so that security just becomes paramount throughout every single process.
Yeah, thank you. I really appreciate that insight. I would agree with you wholeheartedly about Platform One, the work that they're doing, not just within the Air Force and Space Force, but certainly across the DoD, the services that they brought together, how they're working with agencies and organizations, and most importantly, mission partners. And then, of course, collaborating with industry. I think that is a model to be leveraged and looked at and gain the lessons learned from, certainly. I think, in addition to all the points you made, I would just say it's very, very important for all stakeholders out there to really approach the secure software supply chain in an open and collaborative way. I know our tendency at times is to keep information and data, segregated, isolated, and that's an approach that's worked in the past. But in reality is to achieve transparency, everyone's got to open the windows and the doors and allow people to see in because that's going to ensure the visibility and traceability of all of the components along the way. So work with your partners, work with industry, and don't try to solve this alone. There's a lot of mind share out there that can be leveraged across industries as well. So from a government perspective, a lot of these problem sets are being tackled in other industries, and that mind share can be leveraged as well. So with that, Arian, as always, it's good to talk and collaborate with you, my friend. And to all of those that you tuned in, we really appreciate your time. Hope you learned something and enjoyed today's session. We'll see you next time.